Hey, good morning, everybody in financial algebra land. This is Mr. Ainsworth, and we're going to get into a little review here on chapter 5 here in financial algebra. And I said little review. I don't know if you can call it little, but here we go. Get your calculators ready to go. It doesn't matter what type you use because a scientific calculator is not required because it's all basic math. However, you do need one to speed up the calculations and everything. I'm going to use Desmos off to the right. You'll notice that I'm split screen here. You can use a TI-84, your phone calculator, it doesn't matter. But you got to participate because you got to get good. And the only way, in my opinion, to get good is by doing, okay? And watching somebody is one thing, but doing it on your own and getting good at it is another thing. And so get interactive here and not only take notes, but check your work. Hopefully you've worked it through already and just using this as a checking tool. Or some of these may be difficult, so you might be using it as a learning tool, but not a copying tool. So you work it through and then press play and then check your answer. So if I were you, one way you could do this is work out the problem, all right, and then hit play and watch the video as you watch the video here and correct your work. Do all your corrections in red and don't erase your mistakes. Find your mistakes, fix them in red, and go through the video. Okay, correct your work. Do a good job because when you test, you have only a specific amount of time and you have to be good. So doing that requires you guys to go through the review and do it right. All right, so let's get started here. So again, this is chapter 5. Mia is considering two job offers. One has an annual salary. Okay, it's annual here, 43.5K. So that's 43.5 thousand. So K is equal to 1,000, or you multiply it by 1,000, and that just shifts the decimal place. And when you convert it to dollars, and the other annual salary is 54.1K. What's the difference? Okay, keyword difference here in weekly pay. So we're gonna have to go from annual to weekly. All right, so we have a couple things to do. So let's get started here. So we're going to take the first salary, which is 43.5K, so 43.5K. So that's 43.5 times 1,000. All right, and when you multiply that, you shift the decimal place 3 places, right? And it becomes 43,500. This is per year. Okay, this is annual. Annual means per year. The other one is 54.1K, and that's 54.1 times 1,000. So you're going to just simply shift the decimal place 3 places, right? And you're going to get 54,100 per year. And again, these are annual salaries, and what you want to do is find the difference in weekly pay for these guys. So what you want to do is convert them to weekly. Okay, so those are the annuals. Let's convert them to weekly. Now we know that there's 52 weeks per year, so there's 52 weeks, all right, per 1 year. Okay, so what I'm going to do is I'm going to multiply them by 52 weeks per 1 year. Excuse me, I got it backwards. I'm sorry. I wrote it down 52 weeks per year, but I know that there's 1 year. This is also equivalent to 1 year, all right, per 52 weeks. Okay, per 52 weeks. So I need to multiply it by 1 year for every 52 weeks, because what I want to do is I want to divide this number here, this annual salary, by 52, because there's 52 weeks per year. Notice that the units cancel, years divided by years cancel, and you get dollars per week. Okay, so when you do that, you get 43,500, right? Divide that by 52, and you get about 836. Okay, so this is $836, looks like, in 54 cents per week. Okay, per week. Now the other one, same thing. I want to multiply that by 1 year, right, per 52 weeks. If I'm going to go from annual to weekly, I have to divide it by 52. And obviously it becomes smaller, right? Because that's a smaller unit of salary. So we take 54,000 now, 100, because that's the other salary, divided by 52. And we get a little bit more, it's 1,040. Okay, so this is, so, oops. So $1,040, and looks like 38 cents, all right, per week. WK's week. So now they want to figure out the difference. And the difference, well, you just subtract. So we take the larger one, which is 1,040.38 cents, all right, minus the previous one, 836.54. All right, and what do we get? We get a difference, right? So you subtract, always large minus small, which hopefully makes sense. And then you subtract the 836.54. And you get $203.84. So $203.84. And there's your difference. A simple calculation there, going from annual to weekly, given the fact that there are 52 weeks per year or 1 year for every 52 weeks, however you want to use your conversion factors. Oh, that reminds me. So on this review, okay, you want to show process, okay, and conversion factors. I.e., you got to know how to do it, okay? The units should cancel out. It's just like in chemistry, physics, mathematics, okay? Units cancel out properly just like numbers do, and you have to end up with the right units of measure. Okay, number 2. David owns a construction corporation here. The cost of an ad is for X lines, okay? X is the number of lines. Number of lines here is given by this following piecewise function here. He needs a welder and is placing a 2-line ad. So here X is 2. So we know X is 2. We want to find C of 2. Now the domain right here, this X is the number of lines. Number of lines here. It's called the domain. Since 2 is less than or equal to 3, we're going to use the first piece of the function. So we got to take 35 times 2. And now obviously give us $70. It would cost us $70 for 2 lines. 2 times 35 is 70. Pretty straightforward there. Now for a 7-line ad, okay, you want 7 lines. Got to find C of 7. And that calls for the second part of the function, because if since 7 is greater than 3, then you have to use the second piece of the function. So this one's going to be 105 plus 8 times 7 minus 3, which is 105 plus 8 times 4. Now 8 times 4 is 32, and 32 and 105 is 137. Okay, so the cost here is going to be $137. All right, number 3. And again, if I'm going too fast, just, this is a video, so pause, play, rewind, so on. Okay, so on this one here, Xavier's advertising company charges $17 for the first 5 lines. Okay, that's the first thing we know. And then he charges $9.75 for each additional line. Okay, so it's cheaper if you just go beyond 5. So the break point is 5. Express the cost of an X-line ad, C of X, as an algebraically as a piecewise function. So here we go. So let's develop it here. So for 1 line, it's 1 times 17, or obviously $17. For 2 lines, it's 2 times 17, $34, right? For 3 lines, it's 3 times 17, or $51. For 4 lines, and we got to go all the way up to 5, because that's when things change. So for 4 lines, it's 4 times 17, or $68. When we got 5 lines, it's 5 times 17. That should be 15, 35, 85. So it's $85 for the first 5 lines. So what we just did is, like, when X is less than or equal to 5, all right, given X lines here, is whatever X is times 17, or commonly written as 17X. And that's our first piece of the function, so let's highlight it. Okay, that's our first part of the piecewise function. Now, things change after 5. So when X is greater than 5, like 6, right? When X is 6, you got to pay for the first 5 lines. Okay, that's 85. So you got to pay for that, plus 1 additional line, right? Because if you want 6 lines, it's 1 more than 5, and each additional line is $9.75, so $9.75 more. So you got to pay for $85 plus another $9.75. So if you just type that in, if you don't want to do it in your head, 85 and 9 is obviously 94, so it's $94.75. But if you want to use your calculator, just add 1 additional line cost with $9.75. And like I just said, it's $94.75. Well, yeah, 75. So 94, yeah, $94.75. There we go. Yeah. Okay, so with 2 additional lines. So if you want, whoops, if you want 8 lines, it's, no, 7. Come on, after 6 comes 7. I'm going too fast here. So if you want 7 lines, that's 2 additional lines more than the first 5. So you got to pay for the first 5, so it's always 85 plus 2 additional lines at 975 apiece. Okay, so 85 plus 2 times 975. That's 104.50. So 104.50. All right, with 8 lines, let's just do it a few more times. You have to pay for the first 5 lines plus 3 additional lines, and each one costs $9.75. So you got to take 85 plus 3 times the 975. Okay, and you get 114.25. So 114.25. Now, when you're greater than 5, it's always 85 plus something times 975. But notice something here. For x equals 6, let's say, right here, it's 85 plus 1 times 975. When x is 7, it's 85 plus 2 times 975. When x is 8, it is 85 plus 3 times. And this number here, 3, is 5 less than 8, where before 2 is 5 less than 7, and 1 is 5 less than 6. So it's going to be whatever x is minus 5, right, times the additional cost, which is $9.75, or commonly written as 85 plus 975 times quantity x minus 5. That's the second part of our function. That's when when you're greater than 5. So when you're less than 5, when you're less than or equal to 5 right here, you're 17 times whatever x is. When you're greater than 5, you're in the second part. So the piecewise function is a 2-part function, okay? Is equal to 17x, 17 times whatever x is, if x is less than or equal to 5. All right, 5 is the break point, okay? Then it's equal to $85 plus whatever x minus 5 is times the additional cost of $9.75. That's if x is greater than 5. All right, so 5 is the key number here, the break point when things change. So that's the key number here. Notice that. Okay. So developing the table here helps you figure out what the function is, because things change after a certain amount. In this case, after 5, things change because you have to pay less for each additional line. Okay. Number 4. Christian is paid semi-monthly. His annual salary is $82,400. Question is, what's the semi-monthly salary? So first of all, semi-monthly is like every half month you get paid. So you're going to get paid twice a month. So for example, in February, you could get paid, since it has 28 days, you could get paid on the 14th and the 28th. But in March, which has 31 days, you could get paid the 15th and the 31st. All right, but you're going to be paid 2 times for every month. So the semi-monthly charge, or there's that semi-monthly period here, there's 24. All right, so let's go from annual. Let's take 82,400. All right, this is dollars per year. Okay, and we understand that there's 24 semi-monthly periods. The keyword is semi-monthly. So in 1 year, sorry, just got a little sidetracked there. In 1 year, there are 24 semi-monthly periods. Okay, for each month, you get paid every half month. So, like in April, it's 30 days. So you can get paid the 15th and the 30th. But like I said, months like December, which has 31 days, you may get paid the 16th and the 31st, or the 15th and the 31st. It depends. But there's 24 semi-monthly periods per year, so that's like the magic conversion factor. All right, and you have to take 82,000. So let's do this: 82,400, and you have to divide that by 24. All right, and you get a whopping $3,433.33 if we round it. All right, and that's per semi-monthly period. monthly period, pay period. Okay, so like I said, it's twice a month. For 12 months, that's 24 times a year. That's different than bi-weekly, so remember that. Bi-weekly is totally different. Okay, and number 5 is the opposite. So Logan is paid semi-monthly. His semi-monthly salary is $952.35. So we have $952.35 per semi-monthly period. Okay, as I just discussed, there are 24 semi-monthly periods a year. So 24 semi-monthly periods in 1 year. Notice the conversion factors always cancel out. Like on the previous one, the years cancel out and you get dollars per semi-monthly period. And number 5, the semi-monthly periods cancel out and you get dollars per year. Okay, so whatever we get, we should get dollars per year. And so when you take $952.35 and you multiply it by the 24, okay, you get 22,000. Looks like $856. $40, and this is per year. Okay, so just basic unit conversion here, guys. And like I said earlier in the beginning here, you want to show the units. Okay, show the units. If you're not, you better stop the video and put the units in, because when you're on your free response, you need to put the units in to show me that you actually understand what in the world's going on. Okay, number 6. All right, Hannah works as a waitress at the Cheesecake Factory. Her regular hourly wage is $16.25. She works 40 hours per week. What's her regular weekly pay? So weekly pay. Okay, so I know that she makes $16.25 per hour. Okay, I know that her magic number here is 40 hours. So she works 40 hours per week. Okay, now notice the units cancel. Hours cancel, and it gives you dollars per week. Okay, and like I said, the units must cancel properly to indicate that you're doing this correctly here. So what we want to do is take $16.25 and you want to multiply it by 40, which is your, the amount of time, number of hours you work per week. In this case, you make $640 or $650, excuse me, per week. Okay, this is weekly pay. Now, if she works 50 weeks each year, 46 weeks each year, what's the annual salary? Okay, so let's figure that out. Annually, so let's take this this amount, $650 per week. She only works 46 weeks per year. Okay, she's got to have some kind of vacation, right? So she she doesn't work 6 weeks out of the year. And then we got to figure out her annual. So let's take 650 times 46, and you get $29,900. $29,900 per year. That's her annual. Okay, number 7. Suppose she earns, Melina here, earns $19.50 per hour. Her regular hours are 40 hours per week, and she receives time and a half overtime. Ooh, time and a half. Not double time, but time and a half. Okay, so right there, that's 1.5, all right, times regular pay. That's what time and a half means. 1.5 is 1.5 or time and a half, okay? We want to find her total pay if she works 55 hours. So let's step this out. Okay, let's figure out her regular pay. All right, so step 1. Okay, so regular pay. So over the 40 hours. So here we go. So she makes $19.50 per hour for 40 hours. So we have to multiply that by 40 hours for the week. And we get a number here. So let's let's multiply these. Sorry. So 1950. All right, times 40. Okay, this is a regular work week, and that's 780. So 780, and this is the regular pay. All right, per week. Now we got to figure out her overtime rate. So let's figure that out off to the side. So overtime rate, 0.5. 1.5 times the regular rate, which is 1950. Let's figure this out first. So 1.5 times 1950. All right, 29.25. So her overtime rate, ooh, it's pretty good. Look at this, $29.25 per hour. That's what she's making overtime. For every hour over 40 hours is considered overtime, okay? So what we need to do is figure out the overtime pay. So overtime pay, let's do that. So her new rate is $29.25 per hour. And let me see, if you compare 40 and 55, she works 15 hours overtime. So we have to multiply this number by 15 hours. So we're going to take the $29.25, her overtime rate. You always multiply it by the number of hours worked. In this case, she works 15 hours overtime because 55 is 15 more than 40, right? And then she makes $438.75 more. So $438 her overtime pay. So with step 3, total pay, we obviously have to add these numbers up. So 780, right, plus 438, what is that? So let's figure this out. So 780 plus 438. Of course, you got to type the right numbers in. And when it comes to computers or calculators, you know, incorrect input gives you incorrect output. All right, so correct input gives you correct output. So you got to do it right, is what I'm saying. All right, so you get paid $1,218 and looks like 75 cents total. All right, you got to take your regular pay plus your overtime pay to get the total pay. Right. And that's how it's done. And by the way, this is real stuff, guys. This is why I love this class, is because you can't argue with me that you'll never use this, because you use everything. I mean, at some point in your life, you're always going to use this, which is kind of nice. All right, you're learning. Number 8. See, I wrote a textbook for high school students. She receives 12% royalty. Okay, that's important. 12% royalty on the total sales. Okay, the royalty is always based upon total sales. Keyword total sales. So we got to, figure that out. The book sells for $31.95, and she sold 19,871 copies. Holy cow. Okay, so this will give you the sales. We got to use that. So let's figure out the total sales first. Okay, I mean, how much money was brought in? It's per week. Can you multiply about 19,000? Okay, hang on for a second. My program just crashed on me. This is not good. But that's part of technology. You just gotta learn how to roll with it. So that's what I'm doing right now, is I'm just rolling with it. Okay, here we go. We're back and running here. So we have to multiply these, and let's see what we get. Come on. My program's being funny. Okay. Okay, so 31.95 times 19,871 books. Okay, here we go. And that's going to give us a big number here, guys. So 634,000. So $634,878.45. That's the total sales. Now we got to calculate the royalty, which is a portion of that. Now it says up here we get a 12% royalty. So step 2, we got to calculate the royalty by taking 12% of the total sales. Okay, now that's 0.10 times this magic number here, which is 634,000. So here we go. Got to put our decimal in. Our 12% as a decimal is 0.12 times 634,878.45. All right, and the magic number comes out. She gets 76,185 dollars and basically 41 cents. Wow, that is pretty darn cool. Okay, so if you're a success, then you can make some money, right? I mean, earning that on one book sales is pretty nice. And usually authors, they write more than one book, because that's their living right here. And every time you write a book, you sell quite a bit if you're famous and you're well known and you're a good author. you can make some really, really good money. Okay. All right, number nine, here we go. Now, number 9 here, Joshua sells a magazine part-time. He's paid a monthly commission. He receives 18%, okay, of the first $4,600, and then it changes 12% of the balance of his sales. Now, in this problem, last month he sold $20,250 worth of magazine subscriptions. Okay, so this is the amount that he sold. The question is, what's the commission? Okay. Okie dokie. So we need to figure this out. All right, we got to figure out 18% of 4,600 first. So step 1. So 18% of 4,600. That's 0.18 times 4,600. And you got to get a number here, okay? And, so you just go for it. So 0.18 times 4,600. All right, 800. He gets $828. Now that's on the first part here. Then second step, step 2, you got to calculate 12% of the balance. Okay, so we got to switch percentages. So in this one, it's 12% of the balance. Now the balance, what in the world is that? So it gets 0.12. That's our decimal here. And the balance is found by taking the 20,250 and subtracting the 828. Or excuse me, the 4,600, excuse me. So this right here, 20,250 minus the original amount of 4,600. So let's type this in. So here we go. So let's take 12% and let's multiply it by the balance, which is 20,250. All right, minus the 4,600. All right, and notice we get 1878. So this right here is 1878. This is the answer total here. I didn't step it out. I just did it all on Desmos right here. So this is 1878 here. And then the final, it says how much commission. So step 3, the total commission. All right, well, you got to add up the two, right? So 828 plus 1878. All right, you got to add those two up. Okay, so let's do it. So 828 and then plus the 1878. And notice you get 2,706. So 2,706. That's the total commission on this. And by the way, these commissions. There are a lot of jobs that have commissions. Okay, and the way you calculate commissions is by knowing how to use percentages. And that's why this unit is so cool, is because you guys as seniors are starting to get jobs, and there are many jobs out here that earn a commission. Okay, and so you need to know how to work that and how to calculate that so you can actually calculate your correct pay. Because believe it or not, people make mistakes and they don't calculate it correctly. And if you're not savvy with numbers, you're not going to be able to figure out, what you should be getting paid. All right, and you should be getting paid what you're worth. All right, and what they say that you should be getting paid. All right, number 10. Angela works at Best Buy here, and she receives a $410 per week plus 4% commission on her sales. So there's two things going on here. So she gets $410 per week, and then she also gets 4% commission on her sales. So she gets paid two different ways. She sold, it says here, she sold $215,500 worth of equipment. She also worked 48 hours during the year. Okay, so 48 weeks during the year. So let's figure out her regular pay first. Okay, her salary. So step 1, salary. So she gets $410 per week. She works 48 weeks per year. So we have to multiply this. So we have to take 410 times 48. So she's getting $19,680 per year. Now she also gets the commission. So let's calculate the commission. So step 2, commission. So she gets 4%. The magic number is 4%. So it's 4% of the sales. So that's equal to 0.04 times the sales, which is 215,500. So 0.04 times 215,500. That's $8,620. Now to figure out how much she earned total, you got to add some numbers here. So the total earned, you got to add up the 19,680 plus her commission 8,620 and come up with a total salary. And if you do this, it's 19,680. All right, plus the commission 8,620. You'll notice you get about 28,300. Okay. All right. Moving on. All right, let's get into more of the Section 3 work here. So number 11, Temecula Ford here pays a commission to its car sales staff. They are paid a percent of the profit, okay, that they make on a car, not the selling price. The profit is less than or equal to 1,000, the rate. Okay, so there's different things going on. So let's highlight some certain things here. If the profit is less than or equal to 1,000, the commission rate is 18%. Switch colors. If the profit is greater than or equal to 1,000 and less or equal to 3,000, then the commission is 24% of the profit. And then the third one here, if the profit is above 3,000, well, they get 20% of the profit, 27% of the profit. Okay, where P is profit. Look at that, P is profit. So write an expression, C of P, and write a piecewise function. So here we go. So C of P, X equals profit. Not sales, but profit in dollars. Okay, 3 pieces here. So let's start with the first one in green. If the profit is less than or equal to 1,000, so if P is less than or equal to $1,000, okay, again, this is profit. All right, the commission rate, this is the commission now, is 18%. So you got to take 18% of the profit. You always multiply it by the percentage. Now 18%, you guys know this, but 18% is equal to 0.18. So you got to always take the percentage, 18%, and multiply it by the profit. And that's the case if P is less than or equal to 1,000. Now the second case is this: if the profit is greater than 1,000 or less than or equal to the 3,000. So the way you write that is this. So if you're between 1,000 basically and 3,000, so I'm going to step this out here. So if you're greater than 1,000, then 1,000 is obviously less than whatever the profit is, and then that's got to be less than or equal to 3,000. So you go P, profit, is less than or equal to 3,000. So when you see a variable here in a compound inequality, it basically means between the two, 1,000 and 3,000 in this case, although it could be equal to 3,000, all right, because this is less than or equal to that number, okay? That's if you're between two numbers. You write it as a compound inequality. And if in that case, it says the commission rate is, the magic number is 24%. Now 24% is 0.24. So you got to take your percentage, 0.24, 24%, and multiply it by your profit. That's 24, by the way. Okay. Last one, if the profit is above 3,000, so if P is greater than, not 5,000, but 3,000, it says the rate is 27%, and 27% is equal to 0.27, so it's going to be 0.27 times the profit. You're always going to multiply the percentage times the profit to get the commission for that. Simple multiplication, believe it or not. Okay. Number 12. Aaliyah here is a real estate agent. She earns 7.15% a commission of each sales. After working with a potential buyer for 4.5 months, she sold a house for over $500,000. What is the commission on the sale? Okay, so here we go. To figure out the commission of anything, you got to take your percentage, all right, 7.15%. You shift the decimal 2 places left or divide it by 100, so that's 0.0715. So in this case right here, you're going to take 0.015 and you're going to multiply it by the sale price of the house, And this is what she's making on that one sale. 0.0715, all right, times 547,000. And look at that, she's making, oh, I don't think I put it in correctly here. I see. No, I put it in. Okay, I'm sorry. She's making $39,110.50 on that one sale. Okay, she worked 4.5 months though. You got to keep that in mind. So after 4.5 months of work, okay, that's the key number there in terms of time, she made that much money. So it says in part B, this was her only sale during the 4.5 month period. What was her average salary during this time per month? Average means per month. So you got to divide it by 4.5 months basically. So it's, you got to find the average. Got to take $39,110.50 divided by the number of months, which is 4.5 months. So let's take $39,110.50, divide that by 4.5 months. And so she's basically making, all right, $8,691.22 per month. And that, my friends, is very respectable. Okay, that's why people become real estate agents, because when you sell expensive homes, yeah, it might take 1 to 4 or 5 months to sell them. In some cases, longer if they're super expensive, like in the millions. But the reward is huge. All right, the reward is huge. It's called a commission. All right, number 13. Brian works in a factory, receives $15 per hour and piecework pay of 25 cents per unit produced. Last week he worked 40 hours and produced 1,288 units. Okay, there's two things going on here. So the first one, he's getting an hourly rate. So he's getting an hourly wage here, and he's working for 40 hours. The second thing that's going on is that he gets piecework pay of 25 cents per unit produced, and he produced 1,288 units. That's called the piecework pay, and that's what we want to figure out first. So the piecework pay is going to be equal to the rate, and he gets 25 cents. So it's 25 cents is a dollar, or in dollars is 0.25 per unit, okay? Per unit produced. And then you multiply by how many units. In this case, he produced 1,288 units. Notice that I'm putting the units in. The reason why is because they cancel out and you get dollars, right? So basically, he gets a quarter per unit produced, okay? So when you take a quarter, which is 0.25, and multiply by 1,288, you get $322. That's how much he gets for producing these, whatever these things are, okay? $322. Now, he also gets an hourly wage, and it says to get the total hourly pay, you got to take your hourly rate, which is $15 per hour, right, and multiply it by how many hours, which in this case is 40 hours. So you got to take 15 times 40, which should be 600. So $600, all right, for that week, because he works that many hours per week. All right, and then the question is what is his total pay? Well, so the total is going to be the sum of the two. So 322, the top, the piecework pay, plus the hourly pay, or the regular pay. And then that's obviously $922 right there per week. All right, and that's a little example of piecework pay. Regular pay and piecework pay, very simple. All right, now let's jump into section 5.4. And again, you can use your workbook too, by the way. I mean, it is your biggest resource that you guys have. And so as you go through a review here, have your workbook handy and do what we did back when, during the lesson, all right? Because I'm just, redoing the problems here, basically, changing things up, the names, the numbers, the percentages, the amounts, all that kind of stuff. But it's all the same idea. The only thing that you guys need to do is get good at it. Okay, so let's get good. All right, number 14, Jana's employees' benefits include family health care coverage. She contributes 14% of the cost. Jana gets paid bi-weekly. Underline that, that's important. And $112 is taken out of each paycheck for family coverage. All right, the question is what does their employer contribute? For annually. Okay, keyword annually. All right, so we don't know what the annual cost is for either one of them. We don't know what the annual cost for the entire plan is. So we got to figure that out first. Okay, so in number 14, we got to figure out Jana's annual. So let's figure that out. So we know that she gets paid bi-weekly. Now, bi-weekly, we have to understand something. Let's just do a little review here. Okay, there's one bi-weekly pay period every 2 weeks. Okay, one bi-weekly pay period. Okay, per 2 weeks, bi-weekly every 2 weeks. So, oops. All right, now we know that there's 52 weeks in a year. So we know there's 52 weeks, okay, in 1 year. So because of that, if you take 52 and divide it by 2, all right, and notice the units cancel, weeks cancel out, and you get biweekly pay periods per year. And since 52 divided by 2 is 26, that means that there's 26 biweekly pay periods per year. Biweekly periods per year. The magic number is 26. I'm sure you guys remember that. Okay, so what we need to do to get that her annual contribution, we need to take $112 here, all right? And this is per week, per biweekly check. And we got to multiply it by 26 of these because she does this 26 times in a row. Okay, so we got to figure this out, and this will give us her annual contribution. So 112 every biweekly period, multiplied by 26. So $29.12. So $29, $2,900, $12. That is per year. This is her annual contribution, and notice the units cancel out. Biweekly period divided by biweekly period is 1, and you get dollars per year. So now we need to figure out what the total cost of the coverage is. We know that she pays, look at this, she pays 14% of the cost. So step 1, we figured out what her total contribution was. Part 2, number 2, we got to calculate the total cost of the family coverage. Okay, but we do know that 14% of the total cost is $2,912. We do know that because we just calculated that. Her contribution was $2,912. Let's call X the total cost. Because if we know the total cost, then we can figure out what our employer pays, because this total cost is going to be much bigger than $2,912. I can guarantee you that. Okay, so let's continue here. So 0.14 times X is equal to $2,912 divided by 0.14. And X is going to be a bigger number than this. So when you enter in $2,912 and you divide it by 0.14, okay, look what happens. The family plan costs $20,800 total. $20,800 total for the family plan. For the family plan. So she pays this much. She pays $2,912. That's what Jana pays. Her employer pays the rest of it, which is the majority of it, which is kind of nice. That's why benefits are so important when you get a job, because if you had to pay $20,800 out of your salary, that would be way too much money. Okay, so step 3 here, employer cost, or not cost, contribution. All right, it's going to be whatever this total is right here. That's the total minus hers. So it's $20,800 minus the $2,912. So enter in $20,800. That's the total cost of the plan minus her contribution gives the leftover amount which the employer pays. So believe it or not, the employer pays $17,888. Okay, and that, my friends, is the answer to the question. It says, how much does her employer contribute annually? Okay, so what you do is you figure out her annual contribution, then you use the percentage and that number there to figure out the total cost by solving this simple equation. And then after you know the total family plan, the total cost of the family plan, you subtract her contribution from it, and then the leftover, the remaining, is what the employer pays, which, by the way, is a lot more than she pays. The employer pays $17,888, and she only pays $2,912. All right, so benefits are super duper important in real life. Okay, number 15, cruising on, getting there. Revcon here, there are two factors that determine cost of healthcare. An employee makes less than $45,000 per year. He pays $54 per month for individual and $88 for family coverage. Okay, that's the first part. So let's underline and put this in green. So if it's less than $45,000 a year, it's $54 per month for individual and it's $88 for the family coverage. Switch colors. If the person makes over $45,000, at least means $45,000 or more, well, you're going to pay more. So you're going to pay $62 per month for individual, okay? And then for family, you're going to pay even more. Instead of $88 on the previous plan, you're going to pay $112 per month. So we have to know which plan to use. And again, this is like real life stuff. People have to make these decisions, when you're my age and you have a family. I mean, if you're single, you just get the individual plan. If you have a family and you have kids, then you get the family coverage. Because medical insurance is one of the most important things you can have. Trust me, I almost died a couple times and been through the hospital way too many times. And if I didn't have coverage, I would have lost my house multiple times. So trust me, having medical insurance is important. Okay, so in part A, lease makes $42,800 per year. That's less than $45,000. So this right here is less than $45,000. So you're in the first part, the first plan here, option 1. Okay, so this is option 1. Okay, she wants individual. So she's going to have to pay $54 per month for individual. She doesn't want family, she wants individual, so she has to pay $54 per month. Her contribution is 10% of the total cost. What does her employer contribute? Okay, so here we go. Okay, we got to calculate her annual first, just like on number 14. So we got to go annual first. Okay, contribution, that is. So she's going to pay $54 per month. So $54 per month, all right, for 12 months. There's 12 months per year. That's what hers is here. So we got to multiply 54 times 12. Okay, so notice her annual contribution right here. So let me see. Okay, so 648. So $648. This is per year. Per year. Okay, now what we need to understand is that she pays 10% of the total cost. Okay, so step 2, just like the previous one here, we got to calculate the total. So 10% of the total cost is equal to the 648. All right, and we're going to call the total cost X. Okay, so that's we have to calculate 0.1x is equal to 648 and calculate the total. So we divide both sides by 0.10. So 648, all right, divided by 0.1 should be 6,480. So the total cost is $6,480. This is total now. So she only pays 648 out of that total. The employer pays the rest. So what you do to figure out her employer contribution is that you take the total, which is 6,480, minus her contribution is 648. So let's do that. So $6,480 minus her contribution of 648, and oops, I got to type in the right numbers here. So 6,480 minus 648 is $5,832. So $5,832. That's what the employer pays in her case. All right. So what's going on in Part B? Now, in Part B, Summer's annual salary is higher. Okay, she makes 65,400, which is greater than 45,000, so she's option 2. Okay, so let's figure out her annual contribution, that is. Okay, so she wants family health care. And her employee contributes $1,052 per month towards total costs. The question is, oh, it's a different question than the last one. What percent does Summer contribute towards the total coverage? Oh, now to figure out the percentage, you always have to figure out her portion out of the total. So we're going to have to figure out the total amount of this plan again. Okay? So even though it's a slightly different problem, we're still going to have to figure out the total. So to get the total, though, we need to figure out we need to figure out her contribution, her annual contribution. Oh, and then we got to figure out her employer's annual contribution because we're not given a percentage here. And then we can get the total by adding them. So step 1, we're going to figure out her annual contribution. Okay, now she has to contribute, it looks like if she wants family health care, the magic number here is $112 per month. Okay, so this is Summer's now. This is different. So it's $112 per month times 12 months to a year. Okay, what's that? So 112 times 12. Okay, that's $1,344. This is what she contributes per year. Now we got to figure out the employer. The employer's contribution. Now we know that they put in $1,052 every month. So $1,052 every month for 12 months. Notice that the units cancel out nicely, guys. Okay. So what is this? So 1,052 times 12. This is a much bigger number now. They put in 12,624 per year. So to get the total, okay, this is the total family plan now. We got to add these numbers here. So the total family plan is the sum of the two. So 1,344 plus 12,624. So let's add those two together. All right, and we're going to add the 12,624, and we get 13,000. All right, $968. So 13,968 bucks total. Now it says, what percent does Summer contribute towards the total? That's the question. So step 4, the percentage for Summer. So Summer's percentage, basically. Now to get that, I always just take part out of total. That's how I remembered as a little kid. Okay, her portion is $1,344 bucks. All right, the total is $13,968, and you just have to divide and get a percentage. So let's take her portion, divide that by the total, which is $13,968. Notice we get a decimal here, and then to get that decimal, you got to change it to percent. You just multiply it by 100. All right, so 0.09621. All right, times 100. Percent is per 100. You get about 9.6%. All right, so this is equal to 9.6%. All right, rocking and rolling here. Okay, number 16. Let's switch to Natalie here. Now, Natalie works at Chevrolet. Her employer has a pension, all right, offers her a pension. Now, her pension's like a retirement, and that's a good thing. Teachers have pensions. So we put into our pension every month, okay? Oops, change this right here. There's a little typo here, so it's supposed to be Natalie, not Liz. So let's change all these to Natalie. Okay, anytime it says Liz, change it to Natalie. Typo there. So now Natalie works at Chevrolet. Her employer offers a retirement plan called a pension. Natalie's employer uses a formula to calculate her pension. Retired employees get 3.1% of the average salary. Important right here. So her pension, she gets 3.1% of her average salary. And here's the kicker: over the last 4 years, average over the last 4 years, okay, for every year worked, underline that part. That's important. Okay, so we need to calculate the average. So the first step in this problem is to calculate an average, okay, over the last 4 years. So 4-year average. Let's call it a 4-year average. So 4-year average. And that's simply by taking the total sum of that divided by 4. So we got to add up these 4 salaries. So let's do that. All right, so 76,000. All right, plus 76,000. And then plus 78,000. And then the last one's 85,000. Okay, so we have about 315,000 total. Divide that by 4 and we get a 4-year average. So we're going to take that 315,000, divide that by 4. Okay, I'm having fun with my computer right now because it's acting up on me here. So the average salary is $78,750. That sounds about right. Pretty sure. Let's see here. And so let's record that. So $78,750. Okay, that's the 4-year average. Now, she gets 3.1% of it. So the magic number here is 3.1%. 3.1%. So 3.1% of the average. So that's 0.031 times this number here of $78,750. Okay, what is that? So 0.031. All right, times the 78,750. Okay, so she gets $2,441 and looks like 25 cents for every year worked. Now, it says she's worked for 30 years of employment. So right here, if it says for every year works, we get to multiply this number by 30. So her pension, which is her yearly salary, okay, you can interpret it as that, it's going to be 30 times this number here at $24.41, 25 cents. And this is what she's going to retire with every year for the rest of her life in retirement. So we're going to take 30 times $24.41, 25. And look at that. She's going to retire with $73,237.50 per year. Not bad, okay? So it's nice to have pensions, okay? Because that takes care of you when you retire, okay? Because no one can work their entire life. You're going to have to retire sooner or later, all right? I mean, some people can retire, keep on working until their 80s, but it gets just harder and harder. I'm only 53, and it's getting harder and harder. Okay, let's finish up. Dr. Grumman got his first job in 2016. In that year, the government took out 6.2% of the person's income for Social Security until they made $118,500. If they make, if he earned $108,500 in 2016, what did he pay in Social Security? How much did he pay? Okay, well, this is, as you guys know, for Social Security, there's a max. Social Security has a max where Medicare does not. Okay? So even though he earned more than $118,500, they're only going to take 6.2% on this number here instead of what he made. So the amount that he has to pay, so the Social Security, we got to calculate 6.2% of $118,500, which is 0.062 times 118,500. So what does he have to pay for that year back in 2016? So let's calculate it. So 0.062 times 118,500. So he has to pay $7,347 during that year, even though he made more money than the max. Okay, because Social Security has a max where Medicare taxes all income. Social Security does not. They have a maximum taxable income in the table that's given up here. And that's what we're going to get used to here. We're going to use this table, not for exercises 6 through 10, so cross that out. All right, we're going to use this table for the following few problems here. Okay, so let's tackle number 18. All right. So in 2011, percent deducted from Social Security was lowered to 4.2% to help stimulate the economy. So let's look at 2010. Okay, so in 2010, so let's highlight that. Ooh, that's a crazy color there. Kind of hard to see, so let me erase that. So right here in 2010, it's 6.2%. Now in the next year, 2011, they dropped the interest rate from 6.2% to 4.2%. So it lowered. Okay, they kept the max the same. So this is the Social Security max. It says so up here, Social Security maximum taxable income. So that didn't change, but the percentage did. And what that means is that the people in that year in 2011 kept 2% more of their income, okay, out of this number here, out of the 106,800. So they kept more money, and if you have more money, then you have more money to spend, and when people spend, that stimulates the economy. That's why it says stimulate the economy in here. So it says here, how much did the taxpayer earning more than the maximum save? How much did they save in 2011? So instead of 6.2%, it was only 4.2%. So we have to do a couple things. We need to figure out a couple things. In 2010, okay, they would have paid, they paid 6.2% of the 106,800. Okay. So let's calculate that. So that's 0.062. So 0.062 times the 106,800. So they paid $6,621.60 in that year, but in 2011, all right, dropped down to 4.2%, which is 0.042. So 0.042 times the same number, because the max taxable income didn't change. So you got to calculate this number here. So 0.042 times 106,800. Notice that it's less. So they have to pay less. So they have more money to spend. Therefore, they can stimulate the economy if that happened, or it did, because it happened. So the savings in this case is the difference between these two numbers. So it's going to be equal to 6621.60 minus 4485.60. All right, and what do we get? Well, let's figure this out. So 6621, 60 cents minus the other number there, previous number, or the following year's taxable number here. Okay, and notice that we get a savings of $2,136. Okay, moving on. Okay, using the same table here, number 19. Let T of X represent the total combined security and Medicare taxes in 2006. So let's focus in on 2006. Let's highlight that. Okay, so we're talking about the year 2006 combined, okay. Look at this, combined Social Security and Medicare taxes for this year, so for 2006, and we want to write this as express the total, which we're going to call T of X here, as a piecewise function. Okay, so here we go. So let's break this up into parts. Okay, so total combined. So if notice that the maximum taxable income in that year is $94,200. So this is our max taxable income. So something happens when you're less than or equal to that, and then something happens when you're greater than that. So let's talk about the first part. So if X, which represents your income here, let's say X represents your income in dollars. Okay, so if X is less than or equal to $94,200, all right, you have to pay 6.2% of Social Security. Remember, this is Social Security here, and then this part right here, this is Medicare. Okay, so MC for Medicare, Social Security SS. So they're different percentages. So 6.2% on Social Security, 1.45% on all the income. Okay, on all the income. That has no max. Again, no max for Medicare. All right, but Social Security does this. Okay, so here we go. So if X is less than or equal to 94,200, then you have to pay money on Social Security, and you're going to have to pay money on Medicare, where MC is Medicare. So the amount of money that you have to pay, or the amount of tax that you have to pay on Social Security, is always a percentage times the total. So it's 6.2% times this total here. So again, this percentage, 0.062, times whatever X is, less than or equal to 94,200. So times X, all right, plus whatever the income is times 1.45%, which as a decimal is 0.0145. And again, you take the percentage times your income, where X stands for your income. Now, this is only true if X is less than or equal to 94,200. And because these are like terms, you can add them together. So let's just go ahead and add them together. So 0.062X plus 0.0145. Okay, that's 0.0765. So this is 765 times X. And that's true if your income is less than 94,200. This is your first piece of the function. Now, if you go over that, things are look a little bit different. If X is greater than 94,200, all right, you're still going to pay Social Security and Medicare, but since Social Security has a max, you have to calculate it. Okay, and the way you calculate that is by taking 94,200 and multiplying it by your 6.2%. So the max in this case is 0.062 times that number there. Okay, so 94,200. It's not going to go over that. It's going to be that. We'll calculate that here in a minute. Plus the 1.45%, which is 0.0145 times all the taxable income. Okay, so the question is, what is this number here? So we need to calculate that. So 0.062 times 94,200. And that's $5,840.40. So $5,840.40 plus the amount that you have to pay to Medicare, and that's found by taking its percentage times the income. But this right here, this part's going to be constant. So even if you earn $1 million, let's say, which is way over 94,000, you're not going to pay more than $5,840 for Social Security, but you're going to pay a lot more in Medicare, because Medicare taxes all your income that you make over 94,200, whereas Social Security, you max out at $5,840. Okay, it maxes out. That's what I've tried to tell you. So when you put this two-part function together, so here we go. This is our function. Okay, so we'll call our function t of x, t for total, I guess. Okay, and here's your two-part function. So your first part is 0.0765x if x is less than 94,200. That goes up here. So 0.0765x, okay, if the income is less than or equal to 94,200. The second part of your function is right here if your income is greater than 94,000. So Security maxes out at $5,840.40, but you still have to pay a percentage of your Medicare, so 0.0145 times all your income, and that's no matter how much income you have. So if X is greater than 94,200. So even if you make millions, you're going to have to pay the Social Security and then a lot more for Medicare, because Medicare just keeps on going. You tax all your income, not just a portion of it. And that's your piecewise function. Okay, number 20. Mr. Jackson has 2 jobs in 2005. Okay, the first job you earned 74,000 roughly from January to August. Second job 35,000 roughly from August to the end of the year. The employer at the second job took out Social Securities on all, keyword all, okay, of the income, which is not fair, okay? Because when you add these two numbers up here in 2005, it exceeded the maximum. Now in 2005, let's take a look at it. 2005, the maximum taxable income is 90,000. This is for Social Security here. So the question is like, how much over the max are we? So let's step a couple things out. Let's see if you guys can see what I'm talking. So his total salary, okay, was the 74,007 bucks plus 35,311. Okay, and this is way over 90,000. So he was taxed too much. So you take $74,007. All right, and you add, oops, you got to put the number in right. There you go. Plus $35,311, and you get his total salary. So he should have only been taxed on 90,000 out of that, not 109,000. So they took out too much. That's his total salary. Now the maximum taxable is 6.2% of 90,000. So you got to find that. So 0.062 times 90,000. Okay. Oh, actually, well, we'll do that. Oh, well, we can do that now. What the heck? So 0.062 times 90,000. Okay, so they were only allowed to take out this much, 5,580 bucks. All right, but what did they take out? Employer took out 60%, 6.2% of his total. Employer took out, and this is the unfair part, 0.062 times the total, which is 109,318. Okay, and let's figure out what that is, because they took out too much. So they took out $6,777.72. Not fair. That was too much. Okay, this is too much. So he deserves a refund, right? Okay, so the question is what should he be refunded? How much should he be refunded? And so that's your next step in the process right here. So the refund, okay, is equal to this right here, what they took out minus what they should have taken out. So $6,777.72 minus this number, 5,580. So let's type that in. Let's see what we get. So $6,777.72. There's a lot of sevens in there. All right, minus what they should have taken out. And so he gets a refund of over 1,100 bucks. Okay, so he gets a refund of $1,197.72. That's his refund. And guess what? He's a happy guy, because that is going to be a nice check back. All right, and again, this is a video, guys. So go at your own pace. Pause, play, rewind. I'm going as slow as I can. Okay. All right, number 21. Almost done here. Whew. Okay. In 2015, his gross pay was $381,000, very respectable. What's his monthly? Okay, so since it says monthly, we got to take this and divide it by 12. So we take his yearly, okay, and divide that by 12. Okay, and then we get, okay, we get a total of $31,776.55. Okay, that right there is his monthly. So 381, 318. Okay, 60 cents divided by 12. Hopefully I did that right. Okay, so you get that monthly. So this is a 7. Okay, there we go. All right, in what month did he reach the maximum taxable income? Well, in 2015, you got to read the table here. Dun, dun, dun. Let's go back up to the table. Now, let's focus in on 2015. So the maximum taxable income was 118,500. Okay, so in that year, this is the max taxable income for Social Security. And again, there's no max for Medicare. But for this year, 2015, is 118,500. Okay. So the question is like, how many months of getting paid 31,000? All right. How many months of that exceed the maximum? So what we want to do is let X, let's say, equal the number of months, let's say, and do something simple. We want to take 31,776.55, multiply it by the number of months, and the question is when is that equal to 108,500, which is your max? Okay, taxable income. So you simply divide there, okay, and X equals something. So 118,500, and you got to divide that by your monthly salary, which is $31,776.55, and you're going to get a decimal, and it's about 3.7 months. So 3.7 months. So it doesn't happen in the third month. You want to round to 4. So X equals, this is the fourth month. Okay. So it happened in the fourth month. Now it goes January, February, March, April. So this is April. Okay. So it happened in April. Okay. So now, what else? So how much Social Security tax did she pay in February? Well, since the max occurred in April, then she paid the same amount, for the first few months. So we got to calculate that out. She paid 6.2% of the monthly. Remember, go back up to the table here in 2015. She pays 6.2% of the annual, which means she pays 6.2% of the monthly. It's the same thing. Okay, so in February, it's 6.2% of the monthly, which is up here. Okay, which is $31,776.55. So it's 0.062 times this number. So let's calculate that. So 0.062 times your monthly income, 6.2% of it. So $31,776.55, round it. So she pays $1,970 and roughly 15 cents, okay, every month until April, in which she hits her max, okay, until April, every month until April. So every month until April, okay, because she hits her max there. The question is, what does she pay in April? Okay, so let's calculate this. So in January, she pays $1,970.15. In February, same thing. In March, same thing. The question is, what does she pay in April? Okay. So we know the max. What is the max? So we got to calculate the max in year 2015. So we got to sidetrack here. We need the max taxable in 2015. So we got to go up to the table and take a look at that. So we got to calculate 6.2% of the 118,500. Not sure if we've done that yet. Okay, so we haven't. Let's calculate it. So 6.2% of the 118,500. That's 0.062 times 118,500. So let's work that out. So 0.062 times 118,500. That's $7,347 max, okay, per year. Okay, so all of this right here for the first 3 months, let's see if we got close to the max. So let's take 3 times 1970, 15. And notice that we're getting close, see? If we change that to 4, notice we're over the max, okay? So let's change it to 3. So this right here combines to $5,910 and 45 cents. So this right here, April, should be the difference between the two. You got to subtract. Okay, we got to take 7,347 minus what the first 3 months added up to, which is 5,910. All right, and let's get a number there. So 7,347 minus 5,900, $10 and 45 cents. Okay, so what she needs to pay in April is roughly $1,436 and 55 cents. Okay. So yeah, this is it's challenging, guys. You know, that's why it's so important to go through a review, because just because you did it once with me in class doesn't mean you know, you fully understood it and everything. So get involved. Okay, a little bit more. Here we go. Let's take a look at the next problem here in 22. So the table gives a historical look at Social Security and Medicare taxes in the years 2000 to 2016. I only captured a part of it. Ignore this part right here. Okay. And number 22, use the information in the table, which is the same table we've been working with this entire time, to calculate the Social Security, or to examine Social Security and Medicare for 2005. So we're going to be looking in the table here. Okay, so we're going to focus in on this year. It says if X represents income, okay, income, money, okay, what you bring in, your earnings. All right, express the Social Security function, just Social Security, not combined, just Social Security for 2005. And that's why I use S of X instead of T of X, because they want S of X, S standing for Social Security. So we're not going to combine them this time. Okay, so here we go. So let's just go for it. So S of X is for the Social Security is going to be a two-part function. So we're going to pay, we got to pay 6.2% on our max taxable income if X is less than or equal to 90,000. Remember, this represents a max. So anything up to 90,000, we pay 6.2% of it. So 0.062 times X. Again, X is income. It's always a percentage times your income. And that's going to be paid if X is less than or equal to 90,000. Because there's a max. This is the max, as I keep on like repeating myself. Okay. Now, if it's over that, okay, then things change. All right, it becomes constant. So at the max, we got to calculate that. So we got to calculate 0.062 times 90,000. And we got to put a number down here. So 0.062 times 90,000. I think we've done this before. All right, is 5580. So this is equal to 5580, and this is going to be constant. Okay, if X is greater than 90,000. So if you make 100,000, 200,000, 300,000, it doesn't matter. They're only going to take out $5,580. It's not going to increase as you make more and more money. Okay. Now let's see what the graph looks like, and let's see what these functions look like on the graph. So let's plot a few points using the table here. It's going to be easier than you think. All right, and let's take a look at the graph. So let's put in 0 first, because it is possible to make no money, and if that's the case, then you're not going to gain any, or you're not going to have to pay any Social Security tax. So if you don't have any income, then you don't have to pay anything. So it's going to start at the origin. Okay, on this one here, 0, 0. Let's see here. I don't want to use. I'm going to use blue here. So $0 in, $0 made, $0 taxed. Now let's say that X is 10,000. Okay, we're going to have to plot a few points. So we got to go all the way up to that magic number of 90,000. So in order to see something as a graph, you're going to have to plot a few points. So if X is $10,000, you're less than or equal to 90,000. You got to take 0.062 times your income. So 0.062 times 10,000. Okay. Yeah, all you have to do is shift the decimal 4 places. But if you don't know that, you just type it in. All right, you multiply by 10,000, and notice the decimal shifted 4 places to the right, and you get 620 bucks. So they're taxed. Okay, you have to pay $620. That's Social Security tax. Now let's do this for a few numbers here. Okay, how about 50,000? That's still less than 90,000. So you have to pay 0.062 times that 50,000. So 0.062 times 50,000. Notice that you're going to have to pay more, $3,100 total to be exact. And then you come up to the magic number here. Let's suppose you're at 90,000. So you have to pay 6.2% of that, which we already know because we calculated it earlier, which is 5,580 bucks. And after that, things change. It becomes constant. Okay. So let's plot these. Okay. So if you're going to plot these guys, 0, 0 is your first point, 0, 0. And then 50,000 comma 3,100. So you go over 50,000, up 3,100. And I chose the scale of the graph here to make it kind of nice for you guys because the numbers get big. So notice that the scale on this graph is 500. So 0, 500, 1,000, 1,500, 2,000. So every grid line is 500. But go ahead and label so you can graph this and approximate it. So you go right 10,000, up 620. So right 10,000, 10,000. Well, the first grid line is 10,000. So you want to go up 620. So as I said earlier, the first grid line is 500. So the scale is 500. You approximate it. 620 is obviously a little bit higher. So approximate that. And then you got to go 50,000 up 3,100. So 50,000 up 3,100, right about here maybe. And then 90,000, 5,580. So 90,000 is one grid line before 100,000. And then you got to go up 30 or 5,580. So just a little bit higher here. And that's probably not high enough. So right about here maybe. Okay, so 50, oop, nope. That's not high enough. 5,500 is here. 5,580 is a little bit higher, right about here, sorry. Okay, so notice that it's linear there because this is a linear function, as you're going to see on Desmos. We're going to graph this in Desmos as well. So let's go ahead and you should be able to grab a ruler. Okay, so let's do what I'm doing here. I'm just going to grab a ruler. Okay, let me adjust this a little bit. Doing this digital is not as easy as you think. Okay, so my points didn't line up exactly because I need to approximate a little bit better. So let me see here. 20, 3,100. Let me just see, 5,580, 3,100. Yeah, this one should be a little higher here. Okay, so let me try this again. A little bit tougher here than you think. Okay, let's see. That's close enough. Okay, so we get to that magic number here, and then after that, it's constant. Okay, so what do I mean by that? So let's go back to the table. I said if you make over 90,000, all you pay is $5,580. So let's say if X is 100,000, let's say 100,000. All right, all you pay is $5,580. If X is 200,000, all you pay is $5,580. It is constant, okay? Constant. And when that happens for linear function, it happens to look like, oh, I gotta spell this correctly here. It happens to look like a horizontal line, as you're gonna see. So it's a constant horizontal line. It's gotta be flat, okay? So what I mean that, let's plot it. So 100,000, 1 comma, Oh, okay, I know what happened earlier. I looked at the wrong grid line. Oh, I just figured out my mistake. So let me go back here and let me plot this a little bit better here. I just figured out I should be looking at the one grid line before 100,000 and then go up 5580. So should be right about here. Let's see if that lines up now. Let me go back and redraw this line. Okay, give me a second here. Aha! That's what happened. Okay. Simple little mistake. My eyes were off on the grid lines. Okay. And so 100,000 right here, it's the same height. We're at 5,580 approximately, which is right here. It's about that high. And then if you plot 200,000, you go right up and about the same height, it's going to be a horizontal line. So this is y is equal to 5,580. It's constant. And that's your second piece of the function here, which we're going to see in Desmos. Okay, well, we're going to graph this in Desmos as well. I'll show you. Okay, in fact, let's do that right now. So let's split screen it here and let's see what's going on. So let's go to Desmos. And when I say Desmos, I'm talking about the other Desmos here, the graphing calculator. And let's get this going. So believe it or not, you can graph piecewise functions in Desmos pretty easily. Okay, so here we go. Let it get generated. Clear out the previous ones. And let me show you how to put this new function in. It's actually quite simple. So, okay, we're going to type in our first piece of the function. And instead of s of x, we're going to use the notation y. So our first function is y equals 0.062x. Okay, I'm talking about our first piece here. So y equals, so we just type it in, all right? Y is equal to 0.062x. Well, we got to type it in correctly here. So here we go. Now you have to put a restriction in, and you have to say that x is less than or equal to 90,000. So use these curly brackets, which are right on your keyboard, right next to the letter P. They're the curly brackets. Okay, and you got to type in exactly what you see. X less than or equal to 90,000. Okay. Then you have to, oh, and you also have to put it greater than 0 too. So actually, let me put something in here. Let me type in 0 is less than x. If 0 is less than x, that means x is greater than 0. So it's between 0 and 90,000 because money can't be negative. Okay, you can't earn a negative income. So it wouldn't make sense for x to be negative. So make sure you put that little portion in there. So instead of x less than or equal to 90,000, put it between 0 and 90,000 like I did. Now the second part of the function is constant. So y equals 5580. Okay, constant. And put on the restriction. Okay, curly brackets, and type in x greater than, all right, 90,000. Look at, just use the digital keyboard like I'm using. Now you're not going to be able to see the graph too well at this point. So let me expand it. Let me show you something cool on Desmos. Notice the scale is all wrong here. Notice the scale is like up to 12 on the right and up will go up 8. These numbers are huge. So you got to use the gear. So hit your gear setting and we're going to change the units on the x-axis. We want to go from 0 to 6,000 or so. I think that'll be enough, and we can choose 1,000 to be our step. Or 500 actually. Let's do it the same way, 500. And then on the y-axis, I'm sorry. Oh, that was the x-axis. I need to change it here. I apologize. We want to go all the way up to 400,000 on our x-axis. Okay, so let me change this. Sorry. So change that 400,000 because the income grows really big, and then do a step of let me see, 400,000, maybe 10,000. Let's do a step of 10,000, just like we did on our graph paper, like you see in my lesson here. On the y-axis, we want to go from 0 to roughly 6,000 with a step of 500, let's say. The interval there is 500. And I think we're going to be able to see it now. Aha, we can. Okay, so here we go. Now this is what you see on in your review that I printed off for you. Okay, so notice right here at the what's called a cusp. Okay, the cusp is the turning point. So at 90,000, it goes from slope to horizontal because when your income is greater than 90,000, like all these numbers are greater than 90,000. Look at that screen, 97,000, maybe 150,000. Okay, when you go to the right, they're not going to tax you more than $5,580 because Social Security has a maximum taxable income. All right, but up until that point, if you're on the first part, between 0 and 90,000, you're going to be taxed more and more all the way up until it reaches the max taxable income, which is 90,000. Okay, and then things change, and then it becomes constant. So that's what the graph looks like. Okay, and that's how you do it on Desmos. Now it says part C, find the coordinates of the cusp. Okay, the cusp is the turning point, and that's right here. Okay, right there. The cusp is the turning point, and that's happens at 90,000, comma 5,580. So when the income is 90,000, so it goes income, comma amount taxed. That's how you read the cusp. Okay, so when the income's 90,000, your max taxable income right here is $5,580. Okay, there's your cusp or the turning point. At that point, the function becomes horizontal, and that represents a constant linear function because Social Security will not increase after the 90,000. Okay, it is constant, and constant functions always look horizontal. Okay, now let's finish here. So if X represents your income, what is Medicare function? Okay, so in 2005, let me see, that's just 1.45% of everything. Okay, so that part's easy. So the Medicare is 0.0145 times X. It's always percentage times your income. Remember, X stands for income. Okay, and this is graph the Medicare function on the same set of axes. So let's go to Desmos here, and let's type it in. So y is equal to 0.0145x. And notice that a straight line appears, okay? And you wonder, how do you do that by hand? Well, you could develop a table of values again. Okay, so if I just sidetrack here a little bit. Okay, so if I do a little table, okay, so x and then m of x equals 0.0145x. So when the income's 0, you don't pay anything. So it starts at the origin here, just like Social Security did. This does too. Oh, by the way, this is for all income, but x is greater than or equal to 0. So we got to put in that restriction. So let's go curly brackets. Sorry, I should have put this in. So x is greater than or equal to 0. Watch what happens. So it didn't go into the other quadrants. It starts at the origin, and then it just goes upper to the upper right. Okay. And then, but if you're going to do it by hand, you have to enter some numbers in, like, how about, 50,000. So if you type in 50,000, you take 0.0145 times 50,000, and then you figure that out. Okay, so let's go to Desmos here. Actually, let me just stay in this one. Let's do split screen here. Believe it or not, you can do arithmetic in this one here too. You just type it in, and then you want to type in times 50,000. Oops, got to press the time symbol here. There we go, 725. So 725 bucks. So you simply plot that number. So you go right 50,000 up 725. So right 50,000 up 725, which is right about here. So the Medicare would be in this direction here, and then it would intersect the horizontal line this way, and then intersect let's do this again. Somewhere up here. Okay, and then this point here is a special point. We'll talk about that here in a minute. So this is Medicare, and this is Social Security. Okay, and they obviously are equal at some point. What you pay is equal at some income level, and the income level where it's equal is somewhere in here. Okay, pretty sure. Let me get the let me look at the graph here. So let's go back to the graph. Holy cow, I kind of slid over a little bit. Here we go. There we go. All right, so where are they equal? So about so when you reach an income level at about $384,827 roughly, the amount that you pay for Medicare will be the same as you would pay for Social Security. Okay, remember Medicare is the green one. But how do you get that number, you know, algebraically? How do you do that? You know, how do you do that without decimals? Before, so I think my slope's off here a little bit. I think because I'm just no. Yeah, okay. I didn't draw the line totally correctly here, so let me redraw it correctly. Okay, so I can do a better job. So what I should probably do is just grab a line tool. Let's see what here, if I can do this here. Okay, that's not going to work. Let me try that again. This is not easy to do. Let me see. So I got to put it at the origin. Then I got to adjust the points here. Yeah. Okay, so here we go. So it's roughly here somewhere. So in here is our equal point. So the question is, what income level is that? Where the amount that you're making, or you get you're paying as much in Medicare as you are in Social Security. What's that income level there for that to happen? And that's the answer to the last question here. So in 2005, how much money would someone have to be earned? So their payments into Medicare were equal, keyword equal, to the payments to Social Security. Okay, well, they're equal when whatever you pay for Medicare, which is 0.0145 times X, whatever that is equal to this number here, which is your max, 5580. Okay, so we have to solve algebraically. When is 5580 equal to 0.0145 times X, where X stands for your income? Remember, X is income. Okay, so let's figure that out. Let's divide both sides by 0.0145 and let's see what we get. And I sure hope it's a number close to 400,000. It's between 350,000 and 400,000. Okay, so here we go. Let's do that in here. So let's take 5580 and let's divide it by 0.0145. And notice that we get, I put a decimal in there, didn't want that in there. We get $384,827, which happens to be our intersection point right here on the graph. Okay, so that is our answer to the last question. So X is equal to, in this case, what was that number? $384,827.59. Okay, and this is where they are equal. Keyword is equal in the problem. All right. Wow, that was a big one. Okay, so that's all of 20. Holy cow. All right, so you guys out in algebra land, and as in any of my videos here and in reviews, all you have to do is check out any section that you like again, because it is a video and you get to use it to your advantage. All right, and then if you have more questions, just send me a message and remind. I can always meet you on a Zoom call, whatever it takes, okay? But do your best, work hard, make yourself proud, and I'll see you soon.